Unlike some of the other presenters today, I will confess that I'm not the biggest Jam nerd in the sense that I'm not building a Jam implementation. But what I can say is, I work in Polkadot, and I think a lot about applications and application development. And I'm really thinking here about, okay, well, how does Jam impact the average application developer, right? Someone who wants to put something onto Polkadot and get it running. So this is what my presentation is going to be about. It's going to how Jam changes that future for Web3 development for applications. Okay? So, there's actually a lot of really cool narratives around Jam. I think we have a whole day talking about it, and I think that we can go over so many different things that are cool about Jam, whether it be the fact that we have a true technical specification, that allows for people to have multiple implementations building it, that it's bringing coherent environments, has the PVM, actor-based smart contracts, a lot of cores, a lot of execution, a lot of bandwidth. There's so many cool things to talk about with Jam that are all super technical, right? But I think there's actually an even cooler narrative than all of this, and the one that I would want you all to have imprinted in your head. And that is, I think the most important narrative is that Jam evolves Polkadot from hosting just blockchains to a platform for hosting any Web3 application or service. Jam is not just about blockchains anymore. Polkadot is not just about blockchains anymore. It's about Web3 applications and services. So let's take a look at that idea. What is Jam and Polkadot? I think a lot of people have confusion of is Jam something new or different or a change? What is the relationship? For that, we need to start with the basics, okay? The vision of Polkadot. I want to argue that Polkadot is not just a blockchain. Now, Polkadot has a blockchain, it has a token, but I really think when you say Polkadot, when we talk about the people in this room, the meaning, that logo, it is actually talking about a vision towards a world with less trust and more truth. That is really what we're trying to do here. Now, blockchain is one of the ways we get there, but really, this vision is what Polkadot is looking to achieve. And when we talk about less trust, more truth, really that is like the technological embodiment of Web3. So when we say Web3, we say all that kind of stuff, we're really saying the technologies which can provide a world with less trust and more truth. And we talk about Web3, we can look at all of these different properties, things by Andreas Antonopoulos, back in the Bitcoin OG, and also even Gavin Wood. So things like, blockchain being open, public, borderless, neutral, censorship resistant. The Web3 maxims, that you want systems that are resilient, general, performant, coherent, and accessible. These are the kinds of things that we want to build, and that we believe can lead to a world with less trust and more truth. And yeah, obviously, we acknowledge the fact that you can't just change the world with technology. That alone is not going to do anything. You need a lot of other factors here. But I think we really do believe that the first primitive to actually get us started on this pathway is actually through technology, right? And this is why there's such an excitement around the blockchain space. And so this is really the starting point for how you would want to build and get to this world. But remember, it's not the end. There's so much work that needs to be done. And again, this is why Polkadot is not about just blockchains. It's a vision. There's many more steps after we've accomplished this blockchain scaling problem to actually achieve this new world. So then what is the mission of Polkadot right now? Well, our current mission is to build that technology. It's to provide a scalable, secure, and resilient platform for Web3 applications and services. Right? And so that's really all the stuff we've been building, the relay chain, all the work up until now, Jam, has all been about building this first technological primitive. And so how would we do that? Well, first we start with blockchain technology. And I'm not going to go into the history of it, but obviously starting with Bitcoin, then going to Ethereum, making it more accessible for computer programs or any other Turing smart contract. And using blockchain is really one of the ways we can achieve a technology stack with less trust and more truth. And of course, Polkadot's history is all about scaling blockchain technology. So how can we take this first primitive and actually make it more usable, more scalable, right? And of course, I won't go into the history of Polkadot in terms of it providing a heterogeneous, sharded, multi-chain network, but that's the kind of ideas we've been going towards, right? To scale this technology out. But with all of this in mind, there are still limitations. So you could scale a blockchain as much as you want, but there's a fundamental limit about the fact that a blockchain is a chain of blocks. That a block itself can only execute so much in one kind of time window, right? So whenever you're building an application, whenever you're designing something, you have a fundamental limitation. Even if your blockchain can scale to millions of transactions, that it can only do execution within the scope of one block. And this is a big limitation for application developers. So what are the kinds of programs that we've been able to host on blockchain so far with the basic primitives, right? Well, really kind of only two different kinds of apps. We've been able to host smart contracts and host other blockchains, right? So smart contracts, they work as a special kind of program for blockchain because they're designed with the blockchain in mind. They're aware that they're on a blockchain, right? A smart contract has this idea of a gas limit, right? Telling it, okay, at some point you need to stop. And a smart contract system needs to be able to handle stopping at any point in time. So really a smart contract is some kind of very limited program designed specifically for fitting inside of a block. And then also you have blockchain rollups. Well, obviously, if you have another blockchain, and that blockchain is split into blocks, well, it makes it pretty easy to then fit those blocks onto our blocks and then scale it, right? Now, the only limitation here is that, those blocks need to be smaller, or a representation of those blocks, that's like ZK rollups, optimistic rollups, all that kind of idea, representation of the blocks need to be smaller than the blockchain you put it on. But again, you have a program, basically, which is already dividing itself into blocks and then putting itself on a blockchain. This is fine, but this is not the best way to do development, right? So developing on blockchain development has always been its own specialized practice, right? This achieves yet another barrier for achieving this world with less trust and more truth. If we could just make it much more simple to create applications for blockchains, it would actually open up and accelerate our pathway towards this future world. So I want to argue that Jam solves this problem, and specifically with this PVM, the new virtual machine environment inside of Jam. Okay, so let's go into that. So, introducing the PVM. I'm not the best person to introduce it. There's a guy named Jan who actually wrote all this stuff. But, PVM is very exciting. You've been hearing a little bit about it. It's based on RISC-V. It's easy to transpile to all the common hardware. It performs very, very fast, near native speeds. Has all the tooling you would expect from, good developer environment. Cheap gas metering. Fast compilation, and way more. There's a whole presentation we could have on just the PVM. And there are videos, actually, you should go look online that they have it. And so what I would want to say, so PVM with x86 compatibility and the performance already has the ability to run regular programs, right? So you don't have to use the PVM in a blockchain. You can even just use the PVM on a computer or some other virtual machine. And what I'm saying already is that PVM is designed that you can already run regular programs on it. In fact, one of the first demos of the PVM was it running Doom on the computer, right? So this is a great kind of sanity test that, hey, this is a machine and environment that allows any kind of application developer just to launch applications simply, right? But how do we solve the limitation of blockchains? The PVM is just a virtual machine environment. We still have these individual blocks. How can we solve this problem for application developers? And the word here is continuations. Actually, this is a word that I learned yesterday. But Gav was explaining to me this, and continuations really is the solution for how we solve this problem in the PVM, in the blockchain world. So, what is the high-level idea? I'm going to show you here a very simplified, very maybe not perfectly accurate method, but I'll give you an idea. So, when you're running a program, you usually have a stack and some state. And you need to run the program, and the stack fills up. If you don't know about the stack, it has basically two things. You can push onto the stack, or you can pop off the stack, right? So here we have a program which defines a factorial. We're looking for the factorial of 4 here. So let's run this program. We have the stack, it's empty. We call factorial 4, and now we push things to the stack. That's going to call a recursive function, which is going to keep calling itself at each level of the stack until we get to 0. At 0, it can then actually start resolving the stack and start populating the states. Okay, well, 1 is the starting number. 1 times 1 is 1. 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. And we get a final answer, right? So this is basically how a computer program runs. It has some stack, has some state. It runs through. What you can imagine is that if we took a save state of any point in this execution, for example, let me go back. If I just stopped here, for example, and I just gave you this, you would actually have enough information to complete the program. You'd be able to look at the stack, look at the state, and complete the execution. So really, a save state is the ability for the program to kind of pause at any time, and then restart and complete the operation, right? And maybe you can see where I'm going with this. And if you're familiar with this word save state, then you're a gamer like me, and you know that emulators, when you play any kind of NES emulator or Game Boy emulator, they have this function. You can, before a hard boss, you can basically do a save state, and you can exactly save your time right before the boss. You can play the boss and lose, obviously, and then restart the save state and go right back to where you started, without having to play the whole level over again, right? Save states allow you to basically replay the game over and over. And they're doing the same thing. They're basically taking all the memory, all the state, all the stack, saving it somewhere, and then popping it back in and restarting the program. So, the simplified continuations flow, how this kind of looks like on a blockchain. Well, you'd start the program, you run the program to run out of gas. Again, we have block limits. This is the blockchain. We haven't changed anything about that. But then you save all the stack, registers, and memory in a data availability layer. This is a non-persistent memory. So you don't have to store it inside the blockchain state because you're going to use it right away. You just put it in some kind of, non-persistent memory. You wait until the next block, you load all that stuff up again, right? And you continue the program execution. And you can repeat this until the program is complete or you stop paying money or whatever. So the old paradigm of development on applications on blockchain is you have to split up your application, you have to be aware that you're building on a blockchain, split everything up, push it onto individual blocks, nasty. The way it should be, and the way it has been, is that you just build an application, you deploy it to some kind of cloud server, and it just runs. And the Jam way is exactly that. We can abstract from you the fact that you just build an application, you deploy it to our cloud, and we'll split it up for you using continuations, using the PVM and this multi-step state transition function flow. Right? So, really, you can see how Polkadot is just a Web3 cloud. And it always has been. We've been building towards this vision. Right? So really, I want to introduce to you, now with Jam, the Polkadot Cloud. The Polkadot Cloud is the mission. It is the secure, scalable, resilient platform for Web3 applications and services. It has all of these different Web3 services that you'd expect from a cloud provider. It has decentralized execution, settlement and finality, data availability, object storage, blockchain hosting services, smart contract hosting services. These are all the things you'd expect from a cloud provider. These are the things we have been providing all the time, but we've been bundling it up and telling about parachains and talking about blockchains. But Jam takes us to a new state, where it's not just about blockchains anymore. It's about any kind of application accessing and using these Web3 cloud services. The Polkadot Cloud has crazy specifications. It's going to have over 1,000 validators, 341 cores, a Nakamoto coefficient of over 300, 85 times a single CPU load, 852 megabytes of input-output bandwidth, 2 petabytes of data availability, over 1 million transactions per second. This sounds like the kind of platform you would want to deploy your Web3 application on, that one that would actually scale to your needs. So then let's compare. How does our Web3 cloud look like compared to standard Web2 clouds? If you're a web developer, you're coming to this space, are things going to be very weird or they look very similar? Well, we have this decentralized execution service. Well, that looks a lot like Amazon EC2, right? Some elastic cloud compute. If you know about Polkadot's history, we just added all this elastic scaling to it, the core time, the ability to do on-demand purchases. We are providing a similar offering as to a scalable cloud compute with high availability and a price model that helps you the best. This is what we built. Next, object storage service. This is Amazon S3. You can imagine, again, that using the blockchain as a place to store either on the data availability layer for non-persistent memory or for long-term storage on the relay chain itself or on a service like a collator or something like that, right? So now we have an exact kind of duplicate of how we can provide object storage in a cloud but in a Web3 way. And finally, things like AWS Lambda. These are like, running services without thinking about, serverless computing. This is that kind of idea. This is basically a smart contract hosting service. Like when you launch a smart contract, you don't have to think about anything. You just write some code, deploy it to the cloud, it runs and spins up when you need it and scales to when you need it. It is exactly the kind of system that we have expected from Web 2. And we have built it for Web 3. It's just a packaging thing. So really, what I want to say is that Polkadot with Jam is the Web3 internet you've been promised. How many blockchains out there are saying to you, oh, we're going to change the internet, we're going to make a Web3 internet, but they're all working on blockchains and tokens and how they can shield the next meme coin? This is how we expect a Web3 cloud to look like. We are actually building something not just for blockchains, but for any kind of application that wants to absorb the resilience, the strength, the decentralization of a Web3 service. So yeah, Jam in one sentence. Jam evolves Polkadot. So that's the beginning, right? From a hosting just blockchains to a platform for hosting any kind of Web3 application or service. And really, the even simpler sentence is Jam is the beginning of the Polkadot cloud. So what I wanted to do is I wanted to take this opportunity to actually start a discussion. I'm sure there's a lot of application developers out there, right? And people who are building a combination of services or applications directly on the cloud, who are thinking about the future of their parachain, and answer any questions about how they might shift their way they think about the Polkadot cloud and their applications they want to deploy on it. Yeah, okay, thank you. Let's see.
Wow.
Any questions?
Thank you. Thank you, Sean. Awesome. Okay,
Questions?
any questions? Yes, sir.
Maybe I'll start with this. Before you ask your question, does this resonate with you?
Yes, well, not really, but like, Hello. Yes. Okay. Thank you. My question is, you just mentioned DA over there. Yeah. I
Yep.
want to know that are you going to develop a general purpose, commonly used DA services for Polkadot Cloud?
Yeah, so Polkadot already has this, actually. That data availability is packaged in our block space. But you're right. One of the shifts I think that we should have inside of Polkadot is we provide a bundled all-in-one service, right? It's kind of like this whole blockchain hosting service. You get all the DA execution finality all in one.
Yeah.
I think Polkadot Cloud, with this mentality in mind and with Jam, should actually provide more modular packages so that you can access what you want. So for example, you could just use the DA layer on Polkadot to secure an Ethereum rollup or anything like that. That should be exactly the kind of thing we should focus on. We shouldn't say you have to bundle everything here. You can use what you want from our cloud service. But if you use all of our things in all-in-one, you get a much better, cheaper, cohesive experience.
Right. Actually, my question is, are you going to do the DA service separately by yourself? I mean, by Polkadot officially, or you want some third?
Polkadot officially has this. It is part of the Jam paper. This
great.
number, 2 petabytes of data availability with
Great.
352 megabytes, is part of the paper. It's part of the design.
Thank you. Thank you.
Yeah. Actually, I should say this though. If this resonates with you, raise your hand. Okay. Very cool. For the video, that's a lot of our hands. Okay. Any other questions? The Polkadot Cloud. Yes, we have more hands.
GM.
GM.
Can we talk more about the economics and how does that make sense, to deploy on Jam versus other solutions?
Sure. So I mean, economics is the big one because it's multifaceted. Obviously, economics is a big, important part of blockchain because it's part of the security of a blockchain, right? In order for it to be resilient, you need to determine, okay, well, how much would it cost for me to attack this system? Of course, you know that Polkadot provides shared security, and it will have the same model in the Jam world. So every single application and service will inherit the security of Polkadot. For you to attack any application or service on the Polkadot Cloud, it will take it will cost the same attack of attacking the whole network itself. Now, in terms of, as a business, I'm going to go and use this Web3 cloud. Well, I'm going to give some unfortunate news. Using a Web3 cloud is going to cost more than using a Web2 cloud. By nature, right? You have a decentralized system, multiple computers running across the world. In order for you to have any kind of decentralization or redundancy, you need to be able to run multiple servers. It's going to cost more money. So the question is then, as a business, why would I want to use a Web3 cloud if it's going to cost me more money? Well, there's a few reasons. One is if you believe in this cypherpunk mindset, right? You really believe that you want to put your application on a platform that is resilient, that is global, that is open, that I launch it somewhere, I don't have to worry about the local global policies, I don't have to worry about someone taking it down, I don't have to worry about any kind of censorship resistance, anything like that, right? I can just deploy it and know that it will be there and resilient. Now that is good for some kinds of applications, but maybe not the average scenario. Most people probably don't have an app that's so controversial, so to speak. I think another way you can think about the importance of a Web3 cloud is how you get access to your customers, how you can get closer to all of the interactions and the community of your users, right? Normally, when you build a website, all of the actual raw interaction, especially through payments or through how they store data, is all through secondary providers or third-party providers, and you don't really have deep access to that. Imagine, for example, you're launching a gaming application, and rather than depending on PayPal or Steam or someone else to handle all the transactions for you, you directly have access to the transactions. You can add programmability layers to how they transact, for how fees get distributed, how builders of NFTs or other applications will actually be able to tap into those fees and the interactions of your users. That's the kind of system where, again, you cannot find this in Web2 because you depend on centralized source of centralized actors and middlemen who will take those fees. A Web3 cloud will have a little bit more cost, but give you direct access to those fees and those services. And that could be an overall profit for your business.
I think you make a valid point, right? And which is a point, it's something that we should highlight more within Polkadot, which is the value proposition of being aligned with the cypherpunk beliefs, which we don't. But in this context, my question was more towards, in comparison to other servers in Web3, like, for example, you mentioned DA and compute, and in the context of DA, we know that it's it's a commodity, right? Like Celestia's, revenue is way less than what it's doing in volume currently on its token. So how does that look like for Jam, for example? Do we expect the same? What would be the actual service layer or business within Jam that would be most utilized by developers?
Right. I'll say this. An unfortunate news is that I do think that Jam is so powerful that it has built way more supply than there is demand in the whole world. I mean, right now, I think you mentioned Celestia. Celestia has something like 0.15 megabytes per second bandwidth. And Polkadot today, on the current relay chain, before Jam, has about 45 megabytes per second. And we're looking for 850 megabytes per second. Like, it's not even close. But in terms of, like, what I think people are going to use the most or touch the most, I think it's really dependent on the application. I think the main thing is, how do you say, when you build these kinds of applications, you don't necessarily have in mind exactly what people are going to use. And you don't want to either, because if you have an opinionation on the cloud provider of how people should use this app, you basically force how people are going to use it, right? When Gav originally built Ethereum and had the idea of the EVM, I don't think he had in mind the idea of DeFi. He had in mind of building like some other kinds of smart contracts, some kind of legal entity. But DeFi was the thing that everyone adopted on, and they were able to do so because Ethereum was built so generally. I think the idea is for Polkadot to not have that opinionation layer, just to build really nice quality primitives, similar to what you'd expect from Web 2, but with the resilience of Web 3. I don't know exactly how the users will pick and choose and how the economy of Polkadot will be. But again, I do know that at the end of the day, the only way to access the resources from Polkadot is with the DOT token. Literally, there's no, like, you can swap it, you can trade it, but the only thing that the Polkadot cloud accepts for payment is the DOT token. And that will ultimately mean that the DOT token has some inherent value.
I have one last question on the architecture itself. So then could we currently say that the future Jam is to have these decoupled services that are still cohesive? So meaning that if I wanted to launch, Ethereum L2, I could just use the DA layer instead of using everything? Is that how it work? Okay, that's great, right? Because
I think that this is how we should be building towards. And again, once we put into our minds we are actually building a cloud service, it makes much more sense to provide services individually, right? So this is the way I think that we should be building towards.
Right.
And Jam will be going this direction.
While still maintaining the quote-unquote shared security layer, correct?
100%. And also providing, again, a full blockchain as a service solution, where we combine all the things for you and package it for you in the most easy-to-use and cheap way.
Okay, then the marketing angle should be probably the first Web3 or decentralized blockchain as a service.
That's right here, blockchain hosting service.
Yeah.
That's one of it. And ideally, we'll have an Ethereum rollup service as well. All these kinds of things that we can just package on a cloud. Exactly what you expect. Why does Polkadot have to be? Polkadot is not competing with other blockchains. It is not a blockchain. It is a cloud.
Yeah. I don't like the Web3 cloud, but we could figure out a new market.
Okay, over a beer, you and me.
Okay.
Questions? We have in the back.
Now the back, right? First. Hello. So if I want to build a website that's really fast and it connects to Jam, right? Like typically in the Web 2 world, I'd want a server that's like closer to me, that the users can download the assets from and things like that. So does Jam use are Lite clients still compatible with Jam? Like, how would one build something fast?
Yeah, so Polkadot will always be Lite client forward. So Jam absolutely does support Lite clients, and then just all the principles of Polkadot are achieved there. But you won't get, for example, I'm trying to look for this slide. Which one? It's about coherency, right? So let's go back. So all the way beginning. What you won't get from Jam is you won't get this ability to get like, okay, I'm going to target the one server closest to me, because Jam wants to achieve coherency, right? We want to achieve the ability that when you query states, you don't have some kind of discrepancy across different servers, right? So what we talk about here is really like finality, right? So over the course of 18 seconds on average, we get Polkadot finality, and this means that all of the servers across Polkadot agree about the state of something, right? And so it really doesn't matter where you query. I mean, you're querying the cloud, it's a decentralized service. You can, of course, target RPC nodes closest to you, but the idea is that Jam is not going to have some kind of localized optimization there because of its need for global coherency.
Hello. Jam it doesn't use blocks, right? It has no blocks. It's like work packages, right?
Jam underneath the thing is a blockchain.
Oh, it is a blockchain. Okay, so you could have technically like archive nodes that are geographically closer to the user base, things like that.
I think so, absolutely. I mean, someone correct me if I'm not wrong, but Jam is still a blockchain.
Or RPC nodes, okay.
Yeah, so I mean, I think I would say this. If your mindset is already, how can I make a really fast website? I don't know if actually the Web3 cloud is for you. Again, the benefits of the Web3 cloud isn't speed, it's resilience, right? It is a redundancy, right? So this is the kind of thing. I do not think the Web3 future eliminates Web2 services. It just brings in where you need it Web3 services. And it should be as simple to deploy something to the Web3 cloud as it is to deploy to the Web2 cloud. And it should be just like you do architecture across multiple service providers and stuff like that in a Web2 application. You would just think about, how do I integrate the Polkadot cloud into my application development?
Now, I just want to something else, that users don't usually, and developers, unless you're a service developer, they don't usually interact with Jam directly at all. So in that case, you can...
The services of Jam, right?
So you'll be interacting with the servers of the Jam, but you don't interact with the Jam.
Yeah, exactly. Sorry, yeah, exactly.
So that means they would be, for example, core-play servers or smart contract servers, whatever
Exactly.
it's called. Those servers could have nodes like dispute over the world, that you'll be able to use accessing the node of the servers near to you, but they have nothing really to do with the location of the Jam validator, for example.
Sure. Yeah. And we also expect one of the other paradigms with the data availability layer and with Jam is that you could expect to have a lot of services which never actually store stuff into the blockchain state. It just perpetually puts stuff in the data availability layer, right? And reads from memory and uses it, right? So this is kind of an app that's in some way stateless, right? Doesn't actually need to store anything and just will continue to update the memory in the DA. And you can imagine this actually makes a lot of sense. If you have a traditional smart contract. Imagine, me and Keon have a contract about selling a car, and we try to do it over a smart contract. Well, that contract, the execution of it resolves at some point. On existing blockchain platforms, that contract will live on the chain forever, right? What we can actually do is perform this contract only in the DA, in some non-persistent memory. It'll be for a short period of time where we actually resolve the contract, and then afterwards, it's gone. And really, there's no large footprint of that contract or that behavior on the blockchain, as it shouldn't need to be. It is just acting as a consensus service, right? And again, that's a split of the execution service, split from the object storage service, right? Again, in the traditional model, you had a mentality of everything being all in one. You need to use all these things. You can just use raw execution and do nothing. You can just play Doom on the new Polkadot cloud. Wouldn't make a lot of sense, practically speaking, but it can absolutely be done, right?
Hello, Sam. I would like to know about the predictability in Jam, because one of the issues that I always see, especially in enterprise solutions, tell me about that, because we're talking about transactions, and in Web2 it's different, and in Web3 it is linked to the price of a token.
Okay.
It would be flexible in Jam.
Which part is flexible? Do you want the price of the token or the cost of the services?
The price of the fees transactions.
Got it. So I would say this. I think that one of the flexible parts about all of Polkadot is something like that. So as you've seen, very recently, we switched from this auction model for 2-year leases to now the core time model, where things are being auctioned per month and you can buy it in pieces. And there's even discussions right now about whether that model is correct or not. I think that, we will continue to evolve the exact way that you access the Polkadot cloud and how you pay for it and how the costs come to be. End of the day, I will say there's some factors here. One is, for us to have a good cloud, we want to have predictable fees, right? So we should have some kind of system in there where me as an application developer can have an idea of how this would cost over some long period of time. We also want high dynamism, right? So it wants to be like, suddenly my application is getting a lot of traffic. I want to buy more cores. I should be able to do that, right? So that's some of the pieces. But ultimately, exactly how we auction and sell the service and for what price and how the market uses it and all that kind of stuff, that's going to be, I think, a little bit in development. But I think that those kinds of fundamentals is what you can always expect.
All right. Take it.
Yeah.
On Brian's note, I didn't catch it, but one of my questions when you were talking was actually about optimizing some of these services. As part of the architecture implementation, is like co-location of some of these nodes or parts of the components into play? Or are we still saying that we have a decentralized network, we don't co-locate anything or anything geographically for that matter?
My understanding is that's the latter. So I do not think we have we try to achieve full coherency across the entire Jam cloud. Over a finality period.
Okay, cool. Thanks.
But again, I would say this. I think it's because this was asked kind of twice now. This kind of idea. I think once we start thinking in this frame set, there's a lot of problems to be solved, right? This cloud is still very new. How we use this technology is very new. If this is a real need, we should perhaps think about how we can do something like that. Again, you kind of lose some of the coherency, right? So if you have, for example, 3 clusters of jam, which are like, or let's say 7 clusters of jam, all in each continent, right? You could achieve something better locally, right? And then have some kind of bridges, which over the long term, synchronizes those things. That's a perfectly valid idea. But I think in terms of what is the most useful primitive today is actually a fully coherent system. And again, I want to clarify, this is actually very important for Gav and very important for Jam, this idea of a coherent system. Actually, if you look at the Jam paper, the word semi-coherent is literally in the title, right? So this is a big step of how they believe, sorry, let's go back to here, all the principles. This is how they believe, this is the combination of Polkadot and Ethereum. Ethereum is this idea of having a completely coherent state machine, right? And how can we do that with parallel sharding? That is the child of Polkadot and Ethereum. That is why it's written that way. So just look at the preamble of the Jam paper and you'll see exactly that mentioned.
Sure, as long as it doesn't focus on storage, right? Because that's where, essentially you need co-locations and stuff like that. Otherwise, it becomes like garbage, like IPFS.
Yeah.
Thanks.
Any other questions? Yeah, one more in the front.
From a programmer's perspective, so what I would expect from a cloud platform is just what I'm using today with AWS or other cloud services is like general purpose compute.
Yes.
General purpose storage.
Yes.
And general purpose connectivity.
And that is exactly what we want to provide, absolutely, yes.
Yeah, I was just wondering, so if, how is a programmer going to utilize Jam deploying their general purpose programs? Is it going to be directly to Jam or is it going to be through the services deployed on Jam?
So, as I understand, you can deploy a service directly onto Jam. But I think that more likely what you'll get is actually a bunch of kind of these package services that you'll be able to access one layer above, right? So I don't expect the average developer to actually directly program something on Jam, but actually to use the existing services that we create and put them together into a cohesive application. But my understanding is that, again, you can, just like we created any of these services to begin with, like we will create CorePlay, you can, of course, program at the Jam level directly, right? Okay. Services.
Thanks.
Maybe, I think Brian wants to... Great. And this is the difference between someone who actually programs Jam and someone who talks about Jam.
Yeah, I just want to elaborate a bit more about it. Like, for example,
Please.
with the CorePlay, like one of the ideas is that you can run a program indefinitely inside Jam. For example, you write a forever infinite loop. It will run infinitely as long as someone pays the fee for it. But how it actually works is that you don't the Jam itself don't support this functionality exactly. Like continuation, for example, is not part of the server, not part of the core feature of the Jam. It's something can be enabled by Jam. So there needs to be a service that to implement this. So like for example, when you run a program, when you want to post the program, you need to take a snapshot of the memory and then chunking the memory into chunks and then putting the chunks into the data availability system. And then on the next block, when you want to continue the program, you need to fetching the memory chunks out of the DA, rehydrate from the hibernate mode to setting up the memory from the data chunk in the DA, and then continue the program.
Exactly.
And you need to do this every however many seconds, every block. So the execution is still chunk by block by block. But in terms of program's point of view, it's a continuous execution. And all these things need to be taken care of by the service code. It's not taken care of by the Jam itself. There are a lot of logics. It doesn't need to be part of the core protocol of Jam.
Right, right. Okay, so then I want to leave you with the last thing. I think that with this mindset, everyone in the Polkadot ecosystem can actually reframe what they're doing, how they're building, how they can use Polkadot. I think we think about a lot of different parachains launched on Polkadot today. But actually, in the mentality of a cloud service, you look at these parachains, some of them are actually providing third-party services, third-party cloud services, whether it be like data storage, like Crust, or maybe some AI stuff, like NeuroWeb. Or you actually have end-user applications, perhaps maybe Mythical is a good example of that, who are actually using more deeply Polkadot to build their service. So if you're a builder out there, maybe you should start thinking about, am I building a cloud service, a third-party cloud service for the Polkadot cloud and offering for others to build their apps with? Or am I building an end user application? And think about how you can position yourself in this Polkadot Cloud future and make a more cohesive story for the whole ecosystem. We can't do this alone. And I think really when you're deciding and building a new cloud service, you can actually take a look at all the services we provide and how you can repackage them, make them easier for developers, and give them more cohesive end-to-end stories. So anyway, yeah, thank you so much.
Thank you very much, Sean.
Oh yeah, let me get the slide. One last second, if anyone wants. Okay, thank you.
Take it now.